All right, so let's talk about these scatter plots. Um, so scatter plots are graphs that use points to display numeric data. So write the word numeric here. Numeric data with two variables, and that's also known as bivariate. Bivariate. Bivariate meaning from two different variables. We call it bivariate data. Okay. Uh, Scatter plots can help determine if one variable has an effect on the other, or if there are overall trends, patterns, or associations. So we want the word association. Associatianos. Associations. So in other words, does one thing affect the other? Okay. So could be, um, is there any connection between how many pets you have in your family and how many siblings you have? You can graph the data, you can survey a bunch of people, and you can see what it tells you. Okay. Um, so let's take a look at a situation here, and then we'll discuss it a little bit. Um, so, what's the name of the girl there? Zara surveyed shoppers at a mall to see how many items they'd purchased and the total amount of money they'd spent. Um, she used the data to create a scatter plot shown. So this is the scatter plot. And let's study what we have on each axis. So on the x-axis, she recorded how many items each person bought. And on the y-axis, how much they spent in dollars, right? So do you notice that overall the data kind of bunches up like this? I can draw an oval, in fact. Kind of does this. What's going on here? What do you think? Let's see. Overall, like if you bought like only one or two items, how much did you spend around? One or two items, how much? So we have one person that spent maybe $10, another person spent $30, someone also spent $40. So we're only looking at these right here. And someone spent like $75, just in those two. But how about someone who bought like 8 or 9 items? How much did they spend? So let's go up. Yeah, over 100, over 100. Yeah. So in general, the more items you spend, the more items you buy, what can we say about the amount you spend? It goes higher. That's why we got this kind of graph. I'm sorry? It depends on the item, exactly. So let's look at this guy right here. It's kind of a random point out on the somewhere else. How many items did they buy? 10 items. How much did they spend? 40. So is that following the trend or is it outside the trend? Outside the trend. That'll happen sometimes. Maybe they just bought a bunch of little stuff, right? What can you buy like 10 of that would cost about $40 at the mall? Yeah, maybe shirts were on sale, different tops that were like, obviously $10 each. So maybe they just bought a bunch of t-shirts for $10. and that's how they spent the money. So that's what we call an outlier. Okay, so everybody circle that one, this loner, and we're going to call this an outlier. And an outlier is just a point that's not part of the trend, it's outside. Okay? But would you agree that the more items you buy, the more you spend? Would you agree with that? Focus on this. Focus on this. You gotta learn to focus. Things are gonna get real in high school. Come on. All right. Would you agree? The more items you buy, the more you spend. Yeah? That's in general what we're getting from this. So that's what we're going to be looking at for the next few days. So let's answer this question. How many shoppers did Zara survey? How can we figure that out? Well, that's how many items. That's how many items. How can we tell how many people she surveyed for this? Count the dots. And there's 17. So you count the dots and there's 17. Does the number of items purchased seem to have an effect on the number of the amount of money a shopper spent? Yes. The more items purchased, comma, the more you spend. In general. In general. Now, there's exceptions, and when those exceptions come up, you'll see them right away on the graph. They'll be outside the trend, and we call those outliers. Okay? All right. So these scatter plots, they tend to have what we call an association, a connection between the data. And there's three types: positive, negative, and no association. And this is how they're going to look. Okay, let's start first with positive. So positive is going to trend upwards. Okay, it's going to tend to go upwards. And basically what that means is as one variable increases, the other variable increases. And in parentheses, they say the variables change in the same direction. So an example of that might be, we might be measuring, maybe we're measuring the temperature here on the x-axis. And maybe over here, we're measuring how much ice cream is sold, the amount of gallons of ice cream sold. So as the temperature increases, what can we say about the amount of ice cream sold? Will it increase or decrease as it gets hotter? Increase, right? That would be something like this. All right. We can have a negative association. So let's look at a negative association. So a negative association, it doesn't go upwards, it goes downwards. Do you see that? This one goes down. So this tends to go down. So as a variable increases, the other variable decreases. Okay, and the variables change in opposite directions. Let me give you an example of that. You know how we have the freeway in the back? Now, when there's not very many cars on the freeway, how's the traffic going? Fast or slow? Fast. But then say it gets bunched up. There's a lot of cars on this strip here. So the number of cars, if it increases, what happens to the average speed? It goes down. So that would be a negative association. As the number of cars increase, say we're measuring that on the x-axis, and we're measuring speed on the y-axis, the speed goes down. Okay, that's a negative association. And then we can have no association. So no association, it's just all over the place. Do you see that? Doesn't seem to have any type of pattern. Okay, so the change in one variable has no effect on the second variable. Okay, so that's kind of like, well, say you look at the number of socks in your sock drawer. And then you look at the number of knives, or say the number of forks in the kitchen, right? Is there any connection with how many socks you have and how many forks you have? No, that would be this. Okay? It's just all over. So let's answer these three. They describe situations, and we're going to decide positive, negative, or no association. Starting with number one, the number of shoes a person owns and the number of states they visited. Is there a connection? No. Sometimes we also call this correlation instead of association. It's an association or correlation. Number two, the size in ounces of a steak and the cost of the steak. So the size of the steak, compare that to the cost. Yeah, that's positive. The bigger your steak, the more you're going to pay. Would you agree with that? That's positive. It would be something like this. If you measure the size of the steak here in ounces and the cost, it would look something like that. Okay. Number three, the number of days since watering a plant and the moisture level of the soil. So say you water your plant and you measure it each day, how much moisture. Well, this first day after you've watered it, it would have a lot of moisture, right? Then you measure, keep on measuring it day after day. What's going to happen to that moisture level? Yeah, it would be something like that. That's a negative association. All right. All right. Any questions? We're good with that? Okay. Let's go to the other side. Now we're going to learn a couple more things. So it says strength of association. If data points are close together, the association is strong. And if the data points are widely spread out, the association is what we call weak. So this is talking about how closely, how bunched up the data is. Okay. And next year in algebra, you're going to expand on this and you're going to learn about this correlation coefficient. Sounds like a fancy word. All that means is a number, and that number describes are the data points close together, and how close together are they, or are they spread out, and how spread out are they? Real quick, let's just see here. Would you describe this as a strong or a weak correlation? Strong. They're close together. So this is an example of strong, and this is an example of weak. Okay. How about the type of association? Positive, negative, or no association? Yeah, it's positive. You can always tell because if you loop it around, it's going to go upwards. And this is also. So you could have something that's positive and strong, or positive and weak, or negative and strong, or negative and weak. All right. Now, the other thing we're going to be doing is checking to see if these points kind of tend to form a line or if they don't. So do you see this one here? How would we describe that? Positive or negative? It's positive. And in general, I could split it in half. And that's what we're going to call the line of best fit. So this is linear. If a straight line can be drawn to show the overall trend, so a line here shows the overall trend of the scatter plot, the association can be described as linear. So this is a linear association. It just follows that pattern all the way through. How about this other one? It's like a rainbow. Exactly. That's the best way to describe it. There's a connection, there's an association, but it's not linear. It's actually going to form a curve. So do you see how it increases, and at some point it decreases? Okay. So that's what we call nonlinear. This is linear, and this is nonlinear. All right. Any questions? Okay. So now what we're going to do is we're going to use all this information. We're going to use these 4 scatter plots, A through D, and we're going to answer questions 4 through 7. Okay? Which scatter plot or plots shows a linear association? So take a look at these. B and C. Does everyone agree that, look at this. That's linear. And that's linear. So B and C are both linear. Let's look at number 5. Which scatter plots or plot show a nonlinear association? Do you see that A and D form curves? Here's that rainbow we were looking at before. So A and D. Okay, this is exactly the type of questions that you're going to be answering on the Delta Math assignment today. Okay? Which scatter plots or plots which one shows the weakest? Which one looks to be the weakest? A, B, C, or D? In other words, which one has the points farthest apart from each other?
No,
C. C has the weakest. Which scatter plot shows the strongest? A. So for the strongest has the points closest together. Okay, that would be the strongest, and this is the weakest. All right, last thing. So for 8 through 10, we're going to draw a line from each scatter plot to the best description of its association, and then to the variable it would most likely represent. Not all choices will be used. So let's do number 8 together. We have these choices here: positive linear, positive nonlinear, negative linear, negative nonlinear, and no association. Which one best describes 8? It's all over the place. There's no association. Okay? Now we're going to connect this to one of these. So read these three situations: the temperature outside and the total gallons of gas sold at a gas station. That's the first situation. The altitude of a hiker and the total oxygen level in the air. The size of a home and the cost of monthly utilities for the home. In other words, the size of the home and how much you pay for cable, gas, heating, water, electricity, all that stuff. Okay? Which one of these has no association, no connection from one to the other? The first one, yeah. The temperature outside and the amount of gallons you buy in gas have no connection. Okay. So I want you to try 9 and 10. I'll give you some time. Do the same thing with 9 and 10. Connect to something here and connect to something there. Okay? What kind of association can we describe this as? Positive or negative? Now, is it positive linear or positive nonlinear? It's positive linear. And which of the two situations that's left would describe this? The size of the home and the cost of monthly utilities. The larger your house, the more you pay in utilities. Just remember, those of you that want to mention. All right. So obviously the last one, what kind of association is this? Negative and linear. And the only thing left is the altitude of a hiker and the total oxygen. Because the higher you go up in altitude, what happens to the oxygen level? It goes down. All right. So the assignment today is on delta. Okay, and we'll go through it a little bit together. So open your Chromebooks. If you need to borrow one, let me know.